This problem is from photochemistry, and compared to the CUT standards, this is a little bit lengthy problem. So let us see how to calculate this one. You are asked to calculate the moles of carbon monoxide formed during the reaction, moles of carbon monoxide, and you are given with the light irradiated, the wavelength of the light, it is 3020 Armstrong, and also you are provided with the yield of the reaction, which is 0.54, and the total amount of light energy absorbed is given in the unit of ergs, and this ergs is also not a uh, familiar unit. So let us see how to tackle this problem. As I mentioned earlier, this is a little bit lengthy problem. Now you are asked to calculate the number of moles of CO. So number of moles of CO is the question. Now, since it is a 1 is to 1 reaction, meaning to say this aldehyde has reacted to give 1 mole of CO, or one molecule is giving you 1 mole of CO. So, to calculate the number of moles of CO, it is better to calculate the number of molecules of the aldehyde converted. So, our first step is moles of CO, formed is equal to moles of aldehyde reacted, right? So that is fine. So if we calculate the moles of aldehyde reacted, that will be the same. Now for the moles of aldehyde reacted, how to calculate that? You can calculate from the quantum yield. So quantum yield phi is the regular expression. Quantum yield phi is equal to moles of aldehyde reacted divided by moles of photons absorbed. Moles of photons absorbed. So we know if the same number of aldehyde has been reacted as the number of moles of photons absorbed, the quantum yield phi will be equal to 1. But we are given with a phi as 0.54. So it is not that much quantum yield reaction. Now we have to calculate the moles of aldehyde reacted. So what will be the moles of aldehyde reacted? Moles of aldehyde reacted will be equal to 0.54 times of moles of photons absorbed. So now our task is to find the moles of photons absorbed. So that we can write as moles of photons absorbed can be given as total energy absorbed. Total energy absorbed divided by energy of 1 mole of photons. Energy of 1 mole of photons. Of course, that will give you the moles of photons. Now, what is the total energy absorbed? We are given with total energy absorbed is 15,000 ergs. Now, let us calculate one by one. So, we have to calculate the numerator first. Total energy absorbed. Energy is 15,000 ergs. And you have to convert it into joules. 15,000 ergs is equal to, this is equal to 15,000 into 10 to the power of minus 7 joules. So I prefer to do all the calculations in single digit. So I will convert it into, this will be equal to 1, 2, 3, 4. So this will be equal to 1.5 into 10 to the power of 4. So this will become 1.5 into 10 to the power of minus 3 joules. We have got that one. Now we have to calculate the denominator, that is the energy of 1 mole of photon. Energy of 1 mole of photon. What will be that one? So that you have to calculate with the E value is equal to, from the Einstein equation, E is equal to h nu, or this can be written as h into c by lambda. Now let us substitute those values. So as we know the units, h will be equal to how much? H is equal to Planck's constant 6.626 into 10 to the power of minus 34, and the units are kg meter square second inverse. Now see, the velocity of light is 3 into 10 to the power of 8 meter second inverse. Lambda you are given with, in the problem it is 3020 Armstrong. So this is equal to 3020 Armstrong. This is 3020 into 10 to the power of minus 10 meter. So if you calculate, if you convert it into single decimal, it will be 3.020 into 10 3. So this will be 10 to the power of minus 7 meter. And this is energy of one photon. So you have to calculate for energy of 1 mole of photon, it will be equal to E into n h nu. This will be n. So here it will be, you have to calculate the more Avogadro number also. It will be 6.023 into 10 to the power of 23 molecules. So once you calculate it, it will convert it into moles. So now we can calculate the moles of photons. So moles of photon will be equal, total energy we have given as 1.5 into 10 to the power of minus 3 divided by, so this is nhc, and lambda will go upwards. So this will be n is 6.023 into 10 to the power of 23 into h is 6.626 into 10 to the power of minus 34, and c is 3 into 10 to the power of 8. So there will be lambda here divided by, so it will be go to up. So this will be equal to, lambda is 3.020. It was 10 to the power of minus 7 meters. So once it goes to up, it will be 10 to the power of into 10 to the power of minus 7 meters. Now you can directly convert to the moles of aldehyde reacted. So this you can substitute in that equation. So moles of aldehyde reacted will be equal to moles of aldehyde reacted will be equal to what will be the 0.54 into this one. So this will be equal to the quantum yield 0.54 into a lengthy equation into 10 to the power of minus 3 into 3.02 into 10 to the power of minus 7 divided by 6.023 into 10 to the power of 23 into 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8. So always it is better to calculate the exponentials in a separate manner. So you can separate it 0.54 into 1.5 into 3.02 divided by 6.023 into 10 into 6.626 into 3 and here it will be 10 to the power of minus 3, 10 to the power of minus 7 divided by 10 to the power of 23 into 10 to the power of minus 34 into 10 to the power of 8. So upon final calculation, this will come to around 2.04 into 10 to the power of minus 9. The value will be 10 to the power of minus 9, and that will be in moles. You can calculate these numericals. So remember, in CUT you cannot use the calculator, so better to do the numericals in the pen and paper itself. You can simplify and get it an approximate value. So this is the answer for this one. So your right option will be option number